Welcome to this series of videos. I will just explain how to convert a primal LPP to its dual form. So here we are given a problem which states to maximize z equal to 3x1 plus 5x2 subject to these many constraints that you can see. So we have to convert to its dual problem. So I will not go into the details of the theoretical aspects of what is this conversion actually mean and so on. So I will just try to explain how do we convert from primal to dual. So this is in its canonical form. So a maximization problem will have its constraints as less or equal to. Even if it's not, then we are going to convert all the constraints to less or equal to. I'll show that in our subsequent examples. So for the time being, this particular problem is given in its canonical form, where it's maximization problem and all constraints are of less than or equal to form. All constraints are of the form less than or equal to. So first we have to introduce new variables called the dual variables. How many? Equal to the number of constraints. So with respect to each of the constraints, we will introduce dual variable w1, w2, w3 and w4. So we are going to have a new dual problem where the problem will be of minimization type because the primal problem is of maximization type. So the dual problem is minimize, let's say w is equal to, now what will be the objective function? The objective function will be obtained from the constant terms from the constraints. So my first variable is w1 and the coefficient will be 50. The second variable is w2, the coefficient will be 35. Then 10 w3 and 20 w4. So this was about the objective function. Now let us look at the constraints, the new constraints. So now how many constraints will be there? The number of constraints will be same as the number of decision variables in the primal problem. So actually the problem which is given to us, that is called a primal problem, from where we are going to form a new problem. So in the primal problems we have two decision variables x1 and x2. So in the dual problem we are going to have two constraints concerning this consisting these four dual variables. Now the coefficients in the first variable, the first constraint will be with 2, 3, 5 and 0. See, x1 is not there in the fourth constraint, so the coefficient will be considered as 0. So subject to 2, take the coefficient of x1 from here and corresponding dual variable. So 2w1 plus 3w2 plus 5w3. Now it's a minimization problem. The dual is of minimization problem, so the inequality will be greater than or equal to. And what to put here? It is the coefficient of the decision variable in the objective function, 3. Now similarly we will find the second constraint. So 6w1 plus 2w2 minus 3w3 plus 1w4, that means simply w4. So we have 6 w1 plus 2w2 minus 3w3 plus w4 will be greater than or equal to the coefficient 5, and all the variables are non-negative. There will be situations where the variables non-negativity will be affected. We will see that in the subsequent examples. Now for this example, just let's revise it once again. We are given a primal problem, that is maximization of z equal to 3x1 plus 5x2 subject to these constraints. So for each of the constraints, we construct w1, w2, w3 and w4, these new four variables. If it has two constraints, then in the dual problem there will be only two variables, and so on. So, and then we form the new objective function. Since the primal is having maximization, the dual will be having minimization. W is equal to the coefficient of each of these variables are the constant terms in the concerning constraint. So 50w1, 35w2 from here, 10w3 from here, 20w4 from here. Now corresponding to, basically it will be easier if you want to just remember like this, that this the first constraint is corresponding to the decision variable x1. This is corresponding to decision variable x1. That means these coefficients will be these 2, 3, 5, these are all coefficients of x1 in the constraint equation, and the constant term will be coming from the objective function, and the second constraint is coming from x2, all the coefficients of x2 with the corresponding dual variables, and the constant will be this one, this 5. So this is it. This is the first problem. In the subsequent videos we will look into some different problems where there will be certain different ways of finding the dual variables. So for this, thanks for watching.